Today we are going to discuss the analysis of a epicyclic gear train. So here the question is, two shafts A and B are coaxial. A gear C 50 teeth is rigidly mounted on shaft A. A compound gear DE with C and an internal gear G. D has 20 teeth and gears with C and E has 35 teeth and gears with an internal gear G. The gear G is fixed and is concentric with the shaft axis. The compound gear DE is mounted on a pin which projects from an arm keyed to the shaft B. Sketch the arrangement and find the number of teeth on internal gear G, assuming that all gears have the same module. If the shaft A rotates at 110 rpm, find the speed of the shaft B. So in the question, we can see that there are two shafts A and B which are coaxial. So you can see that this is the shaft A and this is the shaft B, both are coaxial. Gear C, which is 50 teeth, is rigidly mounted on the shaft A. Okay, so this is the gear C and it is rigidly mounted on this shaft A. So a compound gear DE gears with C and an internal gear G. D has 20 teeth and gears with C and E has 35 teeth and gears with an internal gear G. Okay, so you can see that DE is the compound gear and D is in mesh with C and E is in mesh with internal gear G. Okay, so next the gear G is fixed and is concentric with shaft axis. So you can see that this internal gear G is a fixed thing. Okay, so this is fixed and is in concentric with the shaft axis. The compound gear DE is mounted on a pin which projects from an arm keyed to the shaft B. Okay, so this is the shaft which holds the compound gear DE and it is pinned to an arm. Okay, so this is the arm and it is pinned to the shaft, okay, of DE. So the first question is, sketch the arrangement and find the number of teeth on the internal gear G. Okay, so this is the diagram and its side view is this. So the first question, we have to determine the number of teeth on the internal gear G. Okay, so upon observing this figure, so you can see this much of distance. This is RC. Okay, so this is the diameter of the gear and this will be the radius of the gear. Okay, radius of the pitch circle. So next one is this much of distance and this will be RD, right? So next you can see that this much of distance is the radius of the gear E. Okay, so this is RE. Okay, so this is RC, this is RD and this is RE. Okay, and this radius will be equal to RG. Okay, so you can say that RC plus RD plus RE is equal to RG. So here it is given that all the gears are of same module. Okay, so you can say that module MC equals to MD equals to ME equals to MG. Okay, so what this module is, M is equal to D by T, or in terms of radius it will be equal to 2R by T, right? So what will be the value of R? It will be equal to, R is equal to T into M divided by 2. So here this is a constant value. Okay, so here I am equating all this MC equal to MD equal to ME equal to MG is equal to M. Okay, so now I am going to replace this R with this terms. Okay, so RC will be equal to TC into M divided by 2 plus TD into M divided by 2 plus TE into M divided by 2 is equal to TG into M divided by 2. So you can cancel all this M by 2 from the RHS and LHS. From the above equation you can get TC plus TD plus TE is equal to TG. Okay. So from the question, TC is equal to 50, TD is equal to 20 and TE is equal to 35. So upon summing, TG, the value of TG is equal to 105. So this is your first answer. Okay. So next you have to determine the speed of the shaft B. That means the speed of the shaft. This is the shaft and this shaft is fixed with the arm. Okay. So what actually you have to determine is the speed of the arm. Okay. So before that, I will tell the general procedure for approaching this kind of epicyclic gear train problem. So first of all, you have to develop the equation of motion for each and every gear, then apply the given conditions into that particular equations. Okay. So for developing the equation, what you have to keep in mind is two important things. The first one is module and the second one is velocity. Okay. So when two gears measures, say this is the gear A and this is the gear B. Okay. So when these two gear measures, module should be same. Okay. That means MA is equal to MB. Okay. So what you can tell is dA by TA is equal to dB by TB. Okay. Or dA by dB is equal to TA by TB. And the next is velocity. Okay. So when two gear measures, the velocity at this particular mesh point will be same. Okay. There will be only one velocity. Okay. That means VA is equal to VB or R omega. Omega equal to 2 pi n by 60 will be equal to VB is RB into 2 pi NB divided by 60. So this 2 times RA will become dA into pi and pi cancels off, 60 and 60 cancels off. So the remaining will be dA NA equal to dB NB. Okay. So dA by dB equals to NB by NA. Okay. So this is your equation 1 and this is your equation 2. Okay. So here you can see that the left hand side of these two equations are of same. Okay. So from these two equations, from 1 and 2 implies TA by TB is equal to NB by NA, which implies NA by NB is equal to TB by TA. So when two gear measures, NA by NB is equal to TB by TA. So this is the important relation that you have to keep in mind. If you forgot, you can just derive this equation with the help of this module and velocity. Okay. So next we are going to develop the equation. So for that, you have to draw a table like this, condition of motion. So here we are specifying some conditions. Then the elements. Here we have got one AM, a compound gear, a gear C and gear G. So therefore only we have got only 4 columns. If we have got lesser elements, then the number of columns will be less. If you have got more elements, then your column will be little bit higher. Okay. So here in order to develop the equations, we have got conditions. Okay, so first of all, the first condition is arm is fixed and gear C rotates through +1 revolutions. I would like to tell you something regarding the sign convention. So here you can see that a +1 revolution, that means a positive sign. Okay, so here I am assuming all the positive revolutions as anti-clockwise directions. Okay, that means if gear C is rotating in an anti-clockwise direction, then it is treated as a positive sign convention. Okay, so if any gear is rotating in a clockwise direction, it is treated as negative. Okay, so positive I am assuming to be anti-clockwise. Throughout the entire problem, you have to follow the same sign convention. Okay, so here I am following positive as anti-clockwise. So here the arm is fixed and gear C is rotates through +1 revolutions. So you can see that this is the arm and here the arm is fixed. So the motion for the arm will be 0, right? Then you can see that gear C rotates through +1 revolution. So gear C rotates through +1 revolution. That means it is rotating in an anti-clockwise direction. Okay, so this is in anti-clockwise direction. Okay, so here it will be having +1. So based on this, how this compound gear DE will rotate. So if gear C rotate like this, then gear D will rotate like this. Okay, so this is in clockwise direction. So you have got a minus, and what will be the speed? So here you have to use the formula. That means here NC by ND is equal to TD by, okay, so here C measures with D. So from this, what we need is ND. Okay, so here ND is the required one. So what will be the value of ND? So ND will be equal to TC divided by TD into NC. So here NC is 1. Okay, so you can simply write thus TC by TD. So here minus of TC divided by TD. Okay, so next is gear G. Okay, so gear G is in mesh with the gear E. So you can see that D is rotating in a clockwise direction. So E is also will be rotating in a clockwise direction. Since this G is an internal gear, it will also rotate in a clockwise direction. Okay, so here E and G are in mesh. Okay, so NG will by NE is equal to E divided by TG. So which implies NG is equal to TE divided by TG into NE. So what this NE is equal to? Since E and D are a compound gear, that means NE will be equal to ND. Okay, so it's a compound gear, E and D. Okay, so therefore NE will be equal to ND itself. Therefore what this ND is, which is equal to TE by TG into ND. ND is equal to TC by TD. Okay, so the value will be equal to TE by TG into TC by TD. Okay, so the sign convention. So it is rotating in clockwise direction. Therefore the sign is negative. Okay, so in the next condition, again arm is fixed and gear C is rotating with the +X revolution. So here again arm is fixed, that means arm is 0. Then gear C is rotating with +X revolution, that means it is rotating in an anti-clockwise direction with the X revolutions. Okay, so here +X, or I am just multiplying this 1 with X. Okay, so again I am multiplying this with X. So what will be the value of gear compound gear DE? It will be minus of X into TC by TD. What will be the value of gear G? Gear G will be equal to minus of x into te by tg into tc by td. Okay. Next, what I am going to do is adding plus y revolutions to all elements. That means for arm, gear C, compound gear D, and gear G. Okay. So what this value will become? 0 plus y. That means plus y. So for gear C, it is already there is x. So this will become y plus x. Okay. So here I am going to add plus y. So the equation will become y minus x into tc by td. So here the equation will become y minus x into te by tg into tc by td. Okay. So this is how we are developing the equation for epicyclic gear train analysis. So now we can solve the problem. So the given conditions are gear G is fixed and shaft A rotates at 110 rpm. Shaft A rotates at 110 rpm. Okay. Shaft A means here shaft A is connected with the gear C. Okay. So it means that the rpm is for gear C. Okay. So from this equations, gear G is fixed means that its rpm is 0, right? Table, you can see that the equation for gear G is y minus x into tc by td into te by tg will be equal to 0. Okay, so equal to y minus x into tc is equal to 50 divided by 20 into te is equal to 35 divided by tg is equal to 105, which is equal to 0. So upon solving this, we get an equation y minus 5 by 6 into x is equal to 0. So this is your first equation. So your second condition is that A rotates at 110 rpm. That means for gear C. So you can see that gear C is here and the final equation is this. The second condition is y plus x is equal to 110 rpm. Okay, so this is your second equation. So upon solving these two equations, we will get the value of y as 50 rpm and x will be equal to 60 rpm. Okay, so what we have to find the speed of the shaft B. Okay, shaft B is actually coupled with the arm. So the value of arm, okay, the rpm of arm will be equal to y, which is equal to 50 rpm, and the sense is, or the direction is anti-clockwise. So this is your final answer. Thank you.